Okay, welcome back to part 2 of lesson 2. Hopefully you've all watched the lesson on thinking in radians, and when I mention now something like 3/4 of a pi, you'll know where that is. So let's look at example 1 here. So this is very similar to what we did in lesson 1 with degrees, except now we're working in radians. So first of all, they want us to draw the angle in standard position, then state the principal angle, and then find some coterminal angles, and then all of the coterminal angles. So let's look at the first one here. Theta equals 3 pi over 4. All right, so think of this as 3/4 of a pi. Where would that land? Well, when pi from here to here is divided into 4 pieces, 3/4 of it would be right here. Okay, and then drawing that angle in standard position, there's our angle of 3 pi over 4. Okay, part I done. Okay, double I, state the principal angle. Okay, so principal angle, smallest positive angle, between 0 and 2 pi now, and this is it. So the original angle given is the principal angle. All right, now one positive and one negative coterminal angle. So in degrees, we would add or subtract 360 to get a coterminal angle, 360 degrees. In radians, we add or subtract 2 pi to get a coterminal angle. So we would basically be going 3 pi over 4 plus 2 pi and 3 pi over 4 minus 2 pi. Okay, now those of you not a fan of fractions, I'm going to show you a calculator method in a minute here. Those of you headed towards calculus, you need to know how to work with fractions. So this is how you do it. So first of all, put 2 pi over 1 so that we're both working with fractions on both terms. Then we need a common denominator if we're going to be adding fractions together. So we would be multiplying the top and bottom here by 4 so that we get a common denominator of 4. Then we would have 8 pi. So I'm just going to show an extra step in here. 3 pi over 4 plus 8 pi over 4 would give us, now we can add the numerators, 3 pi plus 8 pi is going to be 11 pi over 4. And there we go. That's a positive coterminal angle. Okay, same idea with the negative 2 pi, except now it would be 3 pi over 4 minus 8 pi over 4, which would give us negative 5 pi over 4. Okay, those of you not a fan of fractions, this is how you would do it on the calculator. You would basically go 3 pi over 4, I'll do this in a different color here, 3 pi, well, sorry, not the pi part. As soon as you put the pi part in your calculator, this is no longer going to be exact. So what you want to do is simply going to go 3 divided by 4, put it over here, 3 divided by 4, and then we want to add a full rotation of 2, now technically 2 pi, but we can't use pi, otherwise it's not going to be exact anymore. Once you do that, then go math fraction, and it will give you a fraction. And then you just want to throw pi back in on your answer. Let me show you on the calculator what that looks like. Okay, so you go 3 divided by 4 plus 2, really 2 pi. Okay, and you get a number like that, right? Then you want to change that to a fraction, so you go math, fraction, changes the answer to a fraction, and there we go, 11 over 4. And then throw your pi back in on your answer, 11 pi over 4. Same idea with the next one. Okay, so should be able to use your calculator, those of you not headed towards calculus. Okay, finally when we want to write an expression involving a principal angle, or basically with the principal angle and states all coterminal angles. So the principal angle was 3 pi over 4, and if we add multiples of a full rotation, but a full rotation now is 2 pi, so 2 pi and multiples, so times n, where n is an integer. Okay, and that would basically be a way to state all coterminal angles for 3 pi over 4. Good, okay. So if you guys want to try the next one, negative pi over 3 on your own, that would be great, and then we'll check back and see if we have the same answer. Alrighty, pause your video, please. Okay, so our principal angle should have turned out to be 5 pi over 3. positive coterminal angle, I took the 5 pi over 3 and added 2 pi, because if I took negative pi over 3, I would just get the angle we already have, which is 5 pi over 3. So we should get 11 pi over 3. Now you could have any other ones. You could have added 2 pi again to get another one, or 2 pi again. There's many, many of them. Okay, and negative coterminal angle, I took negative pi over 3 so that we could be further negative. Subtract 2 pi, and we get negative 7 pi over 3. All coterminal angles could be defined or described as 5 pi over 3 plus 2 pi n, where n is an element of the integers. And there we go. So hopefully we're all good on that. Let's take a look at reference angles, okay, for these ones. And again, just like I suggested before, let's sketch these. So 4 pi over 3, positive angle, so we're rotating this way. 3 over 3 would be here. That's a whole pi. So 4/3 would be down here. And if you watch the video on thinking in radians, this should all be fairly easy. So there we go, that's our rotation angle. Our reference angle is going to be this angle. So if we went 3 over 3 pi to get to here, then 1 more third would make a reference angle of basically pi over 3. Now this is actually fairly logical, although if you need to, you could basically take away pi, or 3 pi over 3, to figure this out. Okay, let's draw the next one. Negative 5/4 of pi, we're rotating this way. Here's 4/4, 1 more quarter, 5/4. The reference angle would be the acute angle between that terminal arm and the x-axis, so here, and that would be basically 1/4 of a pi. Reference angle equals pi over 4. If you can't get it just by looking at it, what you could do is go 5 pi over 4, take away pi, and again use your calculator if you're not a fan of fractions, and you would get 1 pi over 4. Okay, last one, 23 pi over 6. Well, that's gone around more than once, hasn't it? Let's see, 24 over 6 would be basically 4 pi, right? So that would mean 1 pi, 2 pi, 3 pi, 4 pi. We're not quite there. We're like 1 less. So we're like right here, 1/6 less. So there's our rotation angle. Our reference angle is this little angle here, which, as you can tell, 24 versus 23, this is just going to be 1 pi over 6. And that would be our reference angle. Oh, and that's not negative. I just kind of drew a line. Reference angle equals pi over 6. And there we go. Now, one final last topic we have to look at in lesson 2 is arc length. Very important. You'll notice there's a formula on your formula sheet for this. We kind of touched on it already when we defined what a radian was, as in the arc length divided by the radius. When those are equal, you get 1 radian. But this formula in particular is going to be used in other ways in the questions you're about to see. This formula is on your formula sheet. Okay. Theta is the angle measured in radians. That's key because that's usually what everyone forgets, is that the angle is actually in radians, not degrees. A represents the length of the arc around the angle, and R is the length of the radius. So let's put this to work on some questions on the next page. Okay, example 7. A pendulum 30 centimeters long swings through an arc of 45 centimeters. Through what angle does the pendulum swing? Okay, now how do you recognize that this is one of those questions? Well, they mentioned arc, right? Which means this is probably our arc length. In other words, A in that formula of theta equals A over R is equal, the A is equal to 45. Okay, make sure the units here are the same. Okay, now pendulum. Okay, so really if you kind of picture this, here's a pendulum and it's swinging back and forth like this, right? Okay, so the pendulum length is basically like our radius. Okay, and that's going to be used as our radius here in the formula. Through what angle? So we're looking for theta. Okay, so let's put everything in the formula. We would have theta equals 45 for arc length, 30 for radius. Okay, so theta would equal 1.5. Do not put degrees, okay? The angle is automatically in radians, so just to reinforce that, let's put rad, but if you left it blank, it would be assumed to be in radians. They want to the nearest tenth. Remember to do the are you done yet check. Have you answered what was asked for? Angle, yes, in degrees and radians. We're not quite done. We have to do it in degrees. Have you rounded? Yes, nearest tenth. And are there any units? Yes, radians. Okay, now here's the thing. We need to get this in degrees as well. Well, here we go. First part of the lesson, we want to convert 1.5 radians into degrees. So the conversion is, we want degrees, so 180 degrees is equivalent to pi radians. And if we grab the calculator and go 1.5 times 180 divided by pi, we will get 10 to the nearest tenth, 85.9 degrees. Okay, so there we go. We got two answers. One in radians, one in degrees. Good job. Okay, example 8. Calculate the arc length. Okay, this time we're looking for A. To the nearest tenth of a meter of a sector of a circle. Okay, sector is really like, I don't know why I draw that on a grid. We have a circle. Sector is like when you go to eat a chunk of pie, right? This is our sector. Okay, and they want the arc length, which would be this. Okay, with a diameter of 9.2 if the sector angle is 150 degrees. Okay, so first of all, diameter. Wrong. We don't want diameter. What do we want? We want radius. So if we go 9.2 divided by 2, we'll get our diameter of 4.6 meters. Okay, sector angle, 150 degrees. Okay, so this angle here, okay, is 150 degrees. Again, wrong. We don't want our angle to be in degrees. That formula will not work if our angle's in degrees. So let's convert this. Get rid of degrees. 180 on the bottom, pi on top. Let's keep it exact, okay? So we don't have to round yet. So 150 divided by 180 in the calculator, math fraction, you should get 5 pi over 6. And now that's in radians. Okay, good. Let's use our formula. Theta equals A over R. Let's isolate A by multiplying both sides by R. So A equals R theta. R is 4.6. Theta 5 pi over 6. They just want nearest tenth, so we can actually throw the whole thing in the calculator to get an arc length of 12 point, and if you round that to nearest tenth, 0. It was 12.04, so we keep it as 0.0. All right, now units, very important here. The are you done yet check, right? We have calculated the arc length, we've rounded to nearest tenth, but we need units. Now, if the radius was in meters, arc length is also a unit of length, so that would also be in meters. All right, good. All right, very last example. Thanks for hanging in. A circle with center C. Okay, here's our center C. And minor arc, minor versus major arc. This is a minor arc between A and B. The major arc would be this one right here, the bigger one. Okay, but minor arc, so that one, measuring 15.2 centimeters is shown. So this arc length, arc length, there we go, there's our A. Okay, if angle ABC, so that's this angle here, and angle BAC, so that's this angle, measures pi over 6. Find the length of the radius, okay, so we're looking for R, of the circle to the nearest tenth of a centimeter. Okay, well, we know we've got this formula, right? Theta equals A over R. If we rearrange that, multiply both sides by R theta equals A, divide by theta, A over the angle would do it for us. But the angle we need is this angle here, okay? Not these other two. So let's think about how we would get that. We have a triangle here, okay? And if you recall, the sum of the angles in a triangle is 180 degrees. But we're working right in radians, so we want the sum to be not 180 degrees, but pi, right? Because pi is the same as 180 degrees. So if we find theta, we're going to be going pi, 180 degrees, minus pi over 6, minus another pi over 6, and we would get 4 pi over 6, otherwise known as 2 pi over 3 if we reduce that. There's our theta. Let's throw this in the equation. So arc length 15.2 over 2 pi over 3. Calculator time, let's see what we get. And we should get 7.3 centimeters, round to the nearest tenth. All right, hopefully everyone got that and we're all clear on arc length formula and all that. Thanks for listening. We'll see you next time.